Talk about strong and weak acids and bases, and we're going to talk about how they break apart in water. And you're going to see that strong acids break apart pretty much every time, so 100% of the strong acid molecules will break apart in a solution, whereas you don't have that in a weak acid. You only have some of them break apart. But first, let's look at neutral water. Even neutral water contains some hydronium ions, which are acid particles. You could also write them as just H+, and some hydroxide, so the basic component, but at a very low concentration. And if you notice that they're balanced out, which makes the solution neutral because they have the same amount of acid component pieces and base component pieces. If you look at it, and you can notice that the pH is 7. In the next video we're going to talk about the pH scale and where that number comes from. If we look at a strong acid, you can see that there's no undissociated acid molecules remaining. You don't see any grayed out molecules in here. You can only see them separated into its acid component and then what's left, which we're going to call the conjugate base. We'll get to that in another video. Notice that the pH is 2. With the same concentration, a weak acid would give you a higher pH, meaning it's less acidic, and you can see that there's still some of the undissociated acid left in the solution. In fact, most of it is undissociated, while only a small amount of them break apart. This would be like if you looked at a vinegar solution. You would see that most of the acetic acid molecules present stay together, intact, and only some of them dissociate and give off that acid piece. Same deal for strong bases. If you have a strong base, you have relatively high pH, and you can see that all of the molecules have broken apart into producing hydroxide ions. However, if you have a weak base, the dissociation is not quite as strong, and you can see that some of them are still grayed out here, meaning they haven't contributed any basic component to the solution. Also, if you notice, the pH of a strong base at the same concentration as weak base is higher. This is an example of a weak base giving a pH of like 9.5, whereas a strong base at the same concentration would give you a higher pH. So if we come over here, we have a list of some strong acids and bases and some weak acids and bases. For strong acids, we have hydrochloric acid, hydrobromic acid, hydroiodic acid. These are all halogens, or hydrohalides. And then we have some that contain polyatomic ions: perchloric acid, chloric acid, sulfuric acid, and nitric acid. These are pretty much the only strong acids you need to know about. And really, it's not really like this is strong, this is weak. There is a scale that we'll talk about that kind of dictates whether you would call something strong or weak. But most weak acids either contain, if you see carbon in the formula, it's going to be a weak acid. If you see a phosphorus in the formula, it's going to be a weak acid. These are pretty much the only strong ones you know, but just as a quick identifier, if you see carbon or phosphorus, it's going to be a weak acid. Bases, strong bases, alkali metal bases, and alkaline earth metal bases, with the exception of magnesium, really. So all of these you can see contain hydroxide. These are the strong bases. They break apart. These ions are very stable in water, therefore they allow the hydroxide to contribute to the basic nature of the solution. And then the only real weak base that we need to know is ammonia, NH3, and we've talked before about how ammonia can pull a hydrogen off of water and leave a hydroxide ion present in the solution, but it doesn't do it 100% of the time, so we would consider it a weak base. Pause. Okay, so when we're naming acids, what we have to consider is what the anion ends in. So if the anion ends in IDE, you would say hydroblankic acid. And an example of that, I'll wait till that. If the anion ends in ate, we would call it blankic acid, and if it ends in ite, we'll call it blank us acid. So let's apply this over here. I called these three hydrochloric acid, hydrobromic acid, hydroiodic acid. Basically, if you just see one element with an H in front of it, you say hydro and then whatever the element is, and then changing the ending to ic, acid. However, if you see more than one element besides hydrogen, you know that you have a polyatomic ion. And then you have to look to see whether or not that ion ends in ate or ite to determine what you would call the acid. The first one right here, this is the perchlorate anion, so we would call this perchloric acid. This is the chlorate anion, we would call this chloric acid. This one is the sulfate ion. We would call it the sulfuric acid. And this is the nitrate ion, so we would call it the nitric acid. Okay? Then, for the bases, it's really easy because all you do is say the name like you normally would. Lithium hydroxide, just like you're naming any ionic compound. Sodium hydroxide, potassium hydroxide, calcium hydroxide. You just say the name of the metal, cation, and then say hydroxide, which would be the anion. Pause. And because I forgot to include an ite anion to give us an us acid, this would be an example of phosphorus acid because it contains the polyatomic ion phosphite.